We're going to wrap up chapter 1 with a discussion about these things called inverse functions. The idea of an inverse function is we want to go the other way. Inverse functions go the other way. They undo what has been done. And kind of the classic example of this is if I wanted to change something from Fahrenheit into Celsius, we know we can take the equation 5/9 times whatever the Fahrenheit temperature is, subtract 32, and that's going to equal whatever the Celsius temperature is. So if something's 100 degrees Fahrenheit, we could stick that in and calculate out. And 100 degrees Fahrenheit comes out to about 37, almost 38 degrees Celsius. The idea of the inverse is the inverse is going to go the other way. The inverse is going to take Celsius and convert it into Fahrenheit. And there's an equation that does that as well. That equation is 9/5 times the Celsius plus 32 is going to be equal to the Fahrenheit temperature. So if I took that 37, almost 38 degrees of Celsius and put it into this formula, the second formula is going to change that into Fahrenheit and come up with 100 degrees Fahrenheit. Inverse functions go the other way. They're working with the same variables, but we take one variable to get the other, going the opposite direction. So let's formally define this concept of an inverse function. One that goes the other way. The idea is if I take f of some number, I'll just call it a, the answer is going to be some number, I'll call it b. Then there's another function, we might call it g, and it's going to take some number b, and it's going to change that into some number a. Notice it's doing the opposite thing that the f did. F changes a into b, g changes b into a. Thinking about our function machines that we had back when we introduced functions. We might have one function that we call f of x and another function machine that we call g of x. So the idea is if I take an a and dump it into the first function, we'll get a b out. But then if I put that b into the second function, what comes out is the original a that we started with. So the second function machine undoes what the first function machine does. Kind of generic terms is if I take an x and plug it in, we'll get an f of x out. But if we plug that in, we'll get back to the original x. And that's where we get the property that we'll often see with inverse functions, that if we did a composition of f of g of x, with inverse functions, the answer will always be x because they both undo each other and you're just left with the x. When we have inverse functions, though, we don't like to use different letters for them because we want to know how they're related. So for notation-wise, we say the inverse of our f of x function is, we'll do f with a little -1 superscript x. Now that does not mean it's f to the -1 power. That -1 is not an exponent in this notation. That -1 means inverse. So f inverse of x, they're written in green, is the notation we use for inverses. Okay, let's take a look at some examples then of this idea of inverse functions going the other way, switching the domain and the range, switching x and y. Let's look at some examples of how this might work. Let's first say if we know that f of 3 was equal to 7, we should know very quickly then what the inverse of 7 is going to be equal to. Because the inverse is going to go the other way, it's going to go to the original problem of 3, because it's going to map backwards. That can kind of be extended into the idea of a table. Let's say f of x is given by a table where we've got x's and y's, And maybe when x is 5, y might be 3. When x is 7, y might be 9. When x is 11, y might be 6. When x is 20, y might be 2. Well, now if I wanted to make a table for f inverse of x, the idea of the inverse is we're going to switch the x and y variables. So instead of getting 5, 3, the inverse is going to be 3, 5. Instead of 7, 9, the inverse is 9, 7. Instead of 11, 6, the inverse is 6, 11. And instead of 22, the inverse is 2, 20. The inverse is switching those x's and y's. This can also work with a graph. Let's say I've got this graph here for f of x. And I'm going to start with a point at 1, 2, 2, 3, and 5, 4. And I'm going to connect them. You might notice that's one of our toolkit functions, the square root function shifted to the right 1 and up 2. And from our prior video, you should be able to come up with the equation of that being the square root of x minus 1 plus 2 at the end, because that's a shift to the right 1 and up 2. But what we're going to do with this is we're going to think about what we know. First, I'll do a straightforward problem like we would have seen at the beginning of the chapter. If I wanted to know what f of 1 is, that means I want to know when 1 is plugged into the x, what's the y value we get out of that? And we see it goes up 2. We can also read the graph backwards, and I can say if f of x is equal to 4, then what does x equal? Well, 4 is the answer, so we'll go up to 4, and the point that comes with it is 1, 2, 3, 4, 5. So x equals 5. Another way to write this same problem is say, what is the inverse of 4? In other words, what x value matched to 4? And now we can see that that inverse point is the point 5. Let's do one more inverse. Let's say, what is the inverse of our point 2? Actually, we've already done that. So let's do the inverse of 3. So 3 is the output that has now become the input. If I go up to 3 and over to the graph, I can see the x value, the input on the original, was 2. And so our graph can find us an inverse as well. The other type of inverse we often look at is in an equation, or an expression, better said. With expressions, we want to switch the x and y, and the y is really the f of x part. Here's what I mean by that. If we have f of x equals 4x plus 7, well, the f of x is really functioning as the y. And so what we're going to do is switch x's and y's. So the y is going to become an x equals 4. The x becomes a y plus 7. And this gives us our inverse function that we can solve for y. We're going to subtract 7 from both sides to get x minus 7 equals 4y. Divide both sides by 4. And remember, with division, we have to divide the entire thing by 4 to get x minus 7 all over 4. And now that y is alone, we say we have the inverse function of x, which is x minus 7 all over 4. And there is our inverse of the original function that was written at the top in blue. It's your turn now to practice with inverse functions, switching the x's and y's, switching the inputs and the outputs, going the other direction as the domain becomes the range and the range becomes the domain. Take a look at practicing these and let me know if you have any questions.